Two presentations, and then we are going to have a short break, and then afterwards the last presentation, and I think we are going to end up around 3:30, I would assume. You're ready?
Sure.
Great. Ladies and gentlemen, let's continue our program. The next presentation comes from Nordcloud. Chief Technology Officer, Mr. Pasi Katajainen, Enterprise, DevOps and Cloud.
Thank you. Thank you. Just a couple of seconds, I have to change to PowerPoint. Okay, so I'm here today to tell you some things we've learned about introducing DevOps practices together with cloud in big enterprises with multiple application teams, multiple applications, and a lot of legacy hardware as well. Just a starting point. How many of you are technical people with developers, operators, admins? Okay, so most of you. So for you guys, I think this is probably a lot of old news, but hopefully there's something new for you as well. So DevOps, that's, as we know, that's the practice to bring developers and operations together for enabling the whole IT delivery pipeline to be faster and be able to produce a better quality code for production. First, a couple of things about me and our company. I'm the CTO of Finland. Sounds funny. The CTO of Finland of Nordcloud. I've been working as a software developer in different kind of companies, big and small enterprises, startups for the past 20 years. And for the past couple of years, I've spent my time in looking into technologies, tools, the management of everything related to day-to-day operations and software development. Nordcloud, our company, we are a Finnish company founded in 2011, operating in 6 countries, and we focus on the public cloud. We do cloud strategy, cloud migration on automation, managed services, and training for our customers. We partner with Amazon, with Microsoft, with Google on these topics. So, business. DevOps and cloud. DevOps is the promise for faster time to market, faster feature development, cheaper feature development, a better cycle of innovation. And cloud, in our opinion, is one of the biggest tools to actually achieve this goal. This is no news for most of us. But introducing these kind of tools and technologies in a well-established organization, it's tricky. There's a lot of resistance, usually a lot of fear of losing their jobs, losing their roles. How much new things do I have to learn? And even though the tool set, the technical tools for doing the actual DevOps stuff, it's really important and it's fun. But still, we feel that the most important thing is how you bring things in. How do you change the culture? How do you change the organization? How do you manage the whole bringing in of new tools, platforms, technologies? It basically means that everyone in the company, from management to testers to developers to operations, we have to change. And it's really, it comes down to the management. You have to kind of bring in the culture. You have to understand that not everyone feels comfortable with this change. There has to be a really honest and open communication, transparent communication throughout the company. For operations who feel that their tasks are going to be taken away from them, that's a justified fear. But in the end, we feel that in cloud, the admins, the operations guys, those are the ones with really valuable information who can pitch in how to work, what kind of things you have to figure out in the environments, in the networks, even if it's in the cloud or private cloud, data centers. it doesn't disappear anywhere. That's really important information. The way of working just needs to change. Earlier it used to be so that operations guys, they've created these platforms, these solutions, provided that for the developers, and then developers did their magic on top of it, and again hand over to the operations guys. Now we feel that ops, they need to be more like consultants inside the company. Instead of building things by themselves, they experiment on things, they propose solutions for the developers, how to bring in new tools and new technologies in the development cycle, and be part of this cross-functional team in the organization. For developers, you guys need to be more responsible for the software, for the end product you are creating. Instead of just looking at the code in one server, looking at the mobile device, figuring out how it works there, and how your tests run in your particular environment, you have to take the full ownership of that product. Understand how it's working in the production as well, understand how you measure it, how it works perfectly, and try to bring everything this together already in the development phase. And automation, it's the key for everything here. That's the biggest thing about tool sets. I'm not talking about anything else on the technology side today. I'm just saying that tech automation, that's the thing. Everything from the product development, for the deployments, for testing, it has to be automated. It's the same for the management practices as well. You have to take in these, if you will, lean principles. You have to measure the operations of the people as well, not only the technical stuff. You have to be kind of mindful how your organization is doing, how the changes affect the people working in your company. For the cloud, picture. Well, if DevOps tries to emphasize on fast code delivery, continuous integration, and things like this, cloud just enhances that promise. Cloud makes it possible to really, truly be in control of your day-to-day operations. You can instantly create new environments, new instances. You can have separate environments for testing, for development, for QA. It push of a button. You can automate everything there. Traditionally, it was hard to automate things related to networking. Load balancers, firewalls, how do you configure them in the data center? It used to be really hard. In cloud environments, it's really easy, really hard, really easy and really fast to do these things. Moreover, if you do everything once, test it, automate it, and reuse those resources, you can be sure that things you do in the future as well, they match the criteria you set in the first place. You have the security, you have the reliability, you have the stability you've created once in everywhere. Moreover, with the cloud and DevOps, with CI tools, you can enable the developers to be more self-sufficient. Instead of devs asking for the operations guys to help set up things, you can just create tools and tasks in your CI server for the developers to use. Just push a button and they get new environment for their use. And when they're done, you can automatically schedule things to set up. You can save costs in it as well. I'm not saying that public cloud or private cloud is necessarily always the cheapest option, but it enables you to do really clever cost-saving functions there. So, all in all, for me, it makes sense. DevOps plus cloud, it's the easier way of making DevOps successful. If you have the capability of automating the infrastructure creation, the infrastructure teardown, the configuration of all the parameters in your infrastructure, why would you do it? Moreover, for public cloud, you have the capability of using different kind of managed services, whether it's database, message queues, big data analysis. That's really a tremendous asset you should be using as a tool in your DevOps and your cloud arsenal. Instead of you hosting these services, setting up, configuring themselves yourself, you can always kind of use this abstraction level, use the APIs for these services, and let someone else worry about the hosting of it. So from our perspective, what the typical, how we call IT transformation would look like. The customer has some kind of legacy IT environment, which might be just dedicated hardware, virtual machines. They might have some cloudy stuff running as well. They probably follow some kind of agile software development methods, having scrums, having Kanbans, whatnot. But that only applies to software development. They don't normally incorporate the ops guys in as well. They're totally different teams in the organization. They have different duties. They don't necessarily communicate day to day with each other. They only have good automation, CI tools, Jenkins, Bamboo, already up and running, but it's not comprehensive. They don't necessarily have all levels of tests integrated there. They still need some acceptance tests, stress tests, load tests done manually. Someone needs to tweak here, tweak here, just a little bit to make things smooth and be sure that it's ready for production. They might have configuration management in place, sort of, but they only configure the parameters they see fit for the production environment. What needs to be changed, how do you tweak the performance of it. But they don't necessarily include all the possible parameters related to the environment itself. You could configure the addresses, the database passwords, everything. You should think about configuring everything in your environment so you can make it flexible. You don't have to build all the time. And this bad separation between code and configuration ends up then having to build different artifacts for test, for production. And if you have this distinction, if you end up with problems in production, you can never be sure that you can actually catch those same problems in development environment because you basically don't have the same software you're testing. Because of all of this, they quite often have a slow development cycle and are able to deploy to production only once, twice, 3 times a year or once a quarter. Which is, of course, in these days, it's really problematic. A lot of the smaller players they are developing features fast, bringing in new features every week. How do you compete with that? The more we bring big changes to production all at once, there's bigger likelihood of ending up with errors in your product. It's hard to debug the differences. Hard to know what's actually changed in production. If basically all the code lines you are introducing are new. Okay. When we take part in this transformation, what we try to bring to the customer is the full automation of the infrastructure, for example, to start with. That means in the public cloud that everything that's being done, it's with templates, in AWS CloudFormation, in Azure Resource Manager. Everything is done with templates, no manual setups. If you need script above that, but use templates, use Python, use Photo, but don't do manual steps. Introduce tools for developer self-service. You really don't want to have a DevOps team or an Ops team as a bottleneck for your developers. So it's better to fix your CI, bring in new CI, and introduce tasks there that your developers can actually launch the test or the R&D environment for themselves automatically. You don't have to do anything for them. They can start the environment 8 in the morning when they got to work, and when they leave, it can automatically close down. Automate everything. With having all the infrastructure, all the configurations Now, everything is scripted, everything is with templates. You should put everything to version control. Now, this improves to have better auditability in your environment. If something goes wrong, you can easily trace which change actually broke it. Moreover, if you have some, let's say, PCI requirements or regulations, you should still do this. This is really important stuff. Everything, all the changes need to be auditable. Everything in the infrastructure, everything in the application, everything in the configuration has to be in version control. This, of course, then enables the company to have build once, deploy everywhere mentality. If you separate the code and the configuration totally, you can build the artifact once, you deploy it to the test environment, you deploy the configuration there, and boom, it's your test environment. The same for production, same for QA. You can reproduce the system and just change the parameters you're using to run it. You get that. And last but not least, this of course speeds the time from idea to production. You can deliver new features, new fixes, new patches easily to the environment. Continuous delivery, if you will. This, of course, quite often it's not the case. They're always, I say always, but I mean almost always, there's someone who wants to control what goes to production. It's really rare to have real continuous delivery in this enterprise environments. It's a little bit different. Okay, so how do you start organizing these DevOps and cloud chains? What's important there? Should you let the developers start learning themselves with different teams, or should you have centralized control over it? Now, if you have like 1, 2, 3 teams in the company, apps teams, it's different. If you have hundreds of different applications, different teams, you have to consider different things. For startups, of course, it's easy. You want to have your MVP ready quickly, so everyone starts to learn the cloud, the DevOps. You figure out things, you deploy it, you test it, and it's done. For a big organization, you have to think about the consistency of things. What are the risks associated with letting all the developers go and play around in the cloud? What do you expose? Will you end up someday seeing that, okay, I have SSH open the world, you have old web servers running without patches, what are the risks there? Then again, if you control everything and only let the DevOps team, which would be the traditional ops team, control everything, how the cloud is handled, how the DevOps is done, what kind of bottlenecks do you have there? What's the balance between flexibility and standardization in the environments? How much things should be the same in an organization, in the way of working in cloud and DevOps, and how much differentiation should be between the applications, between the environments. One of the key things here, of course, is reuse and security. Reuse, it doesn't matter if you have centralized way of doing things, you can always reuse the templates, scripts, applications, configurations for different applications as well, which can lessen the workload a little bit. Security, if you have centralized way of doing things, you can impose the security in one central place for your infrastructure instead of everyone trying to figure out what security means. So some things to be mindful about. From our perspective, big enterprises especially, quite often they start with small teams, learning the ropes first, trying to figure out how to introduce DevOps, how to improve the CI, how to do the build pipelines there, how to take in cloud. They figure out the best practices with trial and error, and once they are done, you move to some POC, prove that it works, select a good application for this POC, and when that's done, then you start rolling out gradually to other teams as well. So DevOps and cloud security. That's these days it's being talked quite a lot about, and that really is one of the kind of really important questions. It doesn't really matter if you are in the cloud, in a private, public, data center. You still have to secure your application. You have to secure your accounts. You have to secure your data center. You have to secure everything. That's it. Can you trust the public clouds security-wise? Well, personally, I would say yes. You can trust them. They have a lot of. We can discuss this later, but they have a lot of certifications, a lot of audits done that they really don't. The guys who have access to physical hardware, they just can't have access to your data. There's a real logical physical separation between the access. Their data centers, they are top-notch. Everything is secured. You have high availability in the cloud by default. For me, it's clear. I trust them. Of course, if you're really paranoid on the security aspects and about your data, first select where you store your data. It doesn't even need to be in the cloud. It can be somewhere else. If you store in the cloud, select the geographical location where you store it. In the EU, if you're still paranoid, encrypt everything with the keys you manage. That's it. No one can access it. You can have really good security in the cloud. But since everything in the cloud really is created with APIs, with scripts, with templates, you have to be extra careful about the accounts you create, how you manage those credentials, how you access the account. If you remember CodeSpace, a company a few years back, claiming that they had really good DR solutions, so if someone if something happens, you can always retrieve your code. Well, their AWS account got hacked, and the company went bankrupt because they just destroyed the customer data. They didn't know anything about the customer anymore. That was it. So be careful about the access rules. Who has permission where? And this again, in cloud environment, you can easily restrict the access. You don't have to give developers access to the infrastructure at all. You can give them basically SSH access to the servers, and that's it. In DevOps, security should really come in from day one. Now think about the security in your code. Think about the security in your uses of Git, SVN, what do you use for version control. What do you use there? Do you have some clear vulnerabilities you put in there that gives some attackers easy way of figuring out? Don't use your AWS access keys to GitHub. That's a big no-no. And if you have a centralized way of building your infrastructure, you can have that in your build pipeline early on. Do centralized hardening for your infrastructure, for your bastions, for your NATs. Run those hardening scripts often and have it centralized. Only few guys in your organization will be really experts on security. So why not use them? Don't let the teams figure security out by themselves. Have something centralized. So, how to get started with your journey with DevOps and cloud? It's just a matter of a couple of easy steps. First, define the DevOps mode of operation and service in your company. Whether you want to have centralized way of working, whether you start small and increase the knowledge in the company, team by team, or do you want multiple teams to start experimentation at some point, then converge to solutions. You have to figure it out for yourself. Select the technology stack you want to use, the CI tools, testing tools, what kind of antiviral software, what kind of penetration test software you want to use, but use them. And select few of them. Don't try everything. Don't let the developers try everything and use different stuff. Try to figure out what's best for you guys. Bootstrap an initial DevOps team to figure things out a little bit in the cloud or in the data center. Create common templates, common scripts used as a baseline for your development, and use those guys to harden your environment. Create a way of handling the access for your accounts, for your servers, common key management solutions. And try to gradually roll out this new model in the organization. Personally, I think the key for introducing this big change like this, it's communication at all levels. I know for some of us, it's not kind of easy to constantly be happy and cheerful and talk with the guy next to us, but that's how I see it. It's just the ops need to talk with the devs. You have to tell how things are normally done in the Linux environment, and the dev guys probably introduce some of the software development tools for the ops as well. In cloud environment, everyone is a developer. It's not ops and devs anymore. You have to know how to program. You have to do it well. You have to test it. Communication and mutual respect and mutual coaching and teaching, that's really the key here. Okay, that's everything I had to say, how to kind of somehow make it smoother to start the DevOps and cloud journey. If you have any questions, please feel free.
Any questions for Pasi? Okay.
That was easy.
Yeah, that was easy. Thank you one more time, Pasi Katajainen.